Hi guys, welcome back to the channel. How was the previous projects? I believe that you're doing good and your scores are really increasing. Not just the scores, I hope you're doing better in your projects. Okay, today you want to talk about C-Debugging. What is debugging? Actually, if you run down here, you'll see the definition here and what it means. It's actually the process of finding and fixing errors in software that prevents it from running correctly. All right. So it simply means that there are some bugs in this program. There are some incorrect compilations of codes. So you're supposed to look at that code and then solve the problem. All right. So for this task, I'm going to be using my replit, and let's create a replit. And let's call it checks. Okay. Let's call it checks. And then for the first task here, this is what you will do for the rest of the task. I'm going to take my time to explain the last one because I know it is a bit technical, but these ones I will try to rush through because it's simple. You'll simply copy this first, the main file, the main.c. So I'm going to copy this main.c to my replit. I'm going to change this to the main.c file. All right. Then the second thing, I'm going to copy my main.h, which is provided here. So I'm going to copy this, and then I'm going to paste it right here, main.h, and then we're going to have the file here. Okay, so after that, you look at it. What is actually the issue with this code? All right. Now, based on the main.c file above, create a file named 0main.c. That means I'm supposed to create a file by name 0 main.c. Okay, so what is supposed to be in the 0main.c? If you look here, the file must test the function positive or negative values given and give the correct output when given the case of 0. Okay, now you've written this code before. If you remember your last project in functions, you've actually done this. So what you have to do is to go and copy that code and then paste it here. All right, you don't actually need to push it to the GitHub, your GitHub, but just to ensure that what you're doing is right, you just need to copy it and paste it here. Okay, so after that, the program is supposed to give you 0 is 0 when you run the program. That's supposed to be the correct output of the program. You will only need to upload 0 minus main.c and main.h for this task. We will provide our own positive or negative number. You're not allowed to add or remove lines of code. You may only change one thing, just one line of this task. All right. And you're expected to do that in your main.c file, which is given here. So the question now is, what am I supposed to change here such that when I run the program, it's going to give me 0? Now, if you look at this main.c relating to the code you've created, if I try to print this, try to run this, it's going to give me positive or negative I. That means my I is 98. So it's going to say that 98 is positive value. If I run it, I'm going to have an error because I don't have that file here in my main.c and I don't want to copy it now. So just think here, what can I change here such that it will write 0 is 0? You know, what can you change here? Maybe something like this. I don't know, but just try. I don't know. That was just to give you a guideline. Let's turn it back to 98. So think of something here that will give you 0 is 0. Remember that the is 0 is not something you should do. Just the value you will change that will give you 0. I think I've explained that enough. Let's go to the second task. Okay. In the second task here, copy this main file, comment out, don't delete it. Quote, comment out, don't delete it, the part of the code that is causing the output to go into an infinite loop. I think in my last video, I actually explained what is infinite loop, and we saw how the program ran into an infinite loop. So let's just copy this first and try to see how we implement that. This is our main.c file, so I'm going to change my main.c to the present one. All right. Then we come back here. There is nothing else to do. It's just to debug this. All right. So on that basics, I'm going to delete this off, and I'm going to delete this off also. So on this very program, if I click on this run, now notice something. It is not stopping. That's because it is running an infinite loop, right? Let me just stop this. So the question is, which part of this program makes this program to run into an infinite loop? Now, you know that when you talk of infinite loop, is simply saying that there is something that reoccurs. There is something that runs, that loops round at all times. So just look at that task. Which one amongst them is that very command that runs a loop? All right. If you know the command, just comment it out. The only thing you do is to put your slash and then put your, what do you call it? Your star, your asterisk. And in each of the lines, ensure you have your asterisk. Each of the lines, ensure you have your asterisk. Ensure you have your asterisk. And when you're done with the line that has to do with the infinite loop, you close. I'm not saying that a while loop is an infinite loop. I'm only telling you that that's what you need to do if you find out the problem. Okay? So the third one here says, write a program that prints the largest of the three numbers. Just like we normally do, you're going to copy the main file first. And then on your main.c, I'm replacing this with that. Then go back. This is another file, so you copy it also. And then create a new file. You can choose to use the name that you're using or use your own. I'm going to call mine largest of all.c. And then you paste that code here. Okay. Now, if you try to run this code first, it's going to give you an error because there is no main.h and it was not provided here. So you just need to think and provide that main.h. That's not the solution, but just to provide the main.h first. So I'm going to say main.h. Now, which of the files, what am I supposed to have inside the main.h? It is simply this very prototype. So I'm going to copy this and then paste it in my main.h with a semicolon. Okay, so if I run this program now, it's going to run perfectly well. Now, what you're seeing here is that 0 is the largest number. But if you look at the main.c, of course, you'll realize that 972 is the largest number, yet it's printing 0 is the largest number. That's confusing. So first, let's look at the largest of all, because this is where the problem comes from. All right. Now, if you try to analyze this code, if A is greater than B and B is greater than C, largest is A. That sounds correct, right? Because if B is greater than A and B is also greater than C, it means that A is the largest of the number, right? And then if you look down here, it says if B is greater than A and A is greater than C, largest is B. That looks correct. Else largest is C, but that looks correct. But there is something you need to understand, and that is that this logical statement is invalid, is not correct, because it will only return the correct value only when the numbers are in decreasing order. Now, what do I mean by that? If I go to my main.c file and change this minus sign to a positive value, if I run this program, you'll see that 972 will be the correct answer. Of course, you can see this. If I change this 98 to, let's say, 998, it will switch to 998, which is correct. I hope you can see that. That's because the number is in descending order. All right. Comparison between your first value A is greater than C, or B rather, and then A is greater than C. That justifies that answer. But now, each time I bring a negative value, the order is no more valid. Hence, it will not be able to compare, but it will only give you the last value, which is C. Of course, C stands alone. So if I run, it will return back to 0. Okay? So for you to debug this program, you need to make a comparison of a value to a value. That's what I'm saying is your A should either be equal to or greater than equals to B, and then you should have the same A to contest with C. Okay? The same thing is applicable here. While A is trying to check the value in B, or rather in A, you should also check for the value in C. Otherwise, you print C. So if I run this program now, you realize that we have the correct result. So if I go to my main.c, no matter how I try to manipulate, let's say I have minus here, it's going to give me 0. It's the largest number. So if I change here to positive value, you can see that 98 is a positive number. So that is how you make the comparison, not A to B and then A to C. It's going to check only when the number is in descending order. Another way you can actually write this is to use, there are many ways to write it. There are so many ways you can implement this very task. You can simply change this to a ternary operator, and then I can have something like this. I can say A is greater than B, a question mark, that stands for a condition using ternary operator. And then I'm going to say if A is greater than B, then return A. Otherwise, return B. Okay, that's my first step. And this should be stored in the variable of largest. Okay, so if you check those values, anyone that is greater, store it in the variable called largest. Then now use this largest to check if the largest value is smaller or bigger than C, which is the next value. So I'm going to say that at this point, largest will be used to check if largest is greater than C. If that is the case, then return largest, which could be either A or B. But otherwise, C is greater than largest, then return C. So I think that code looks very easy, but it looks technical to understand. So let me run this and see if we have 98 as a result. We have 98. So let's go to the main and make some changes. Let me have minus 98 here and have 972 here. Let's run. Okay, we have 972. So there are many ways you can implement that very task to solve or debug the problem. Okay. The last one here, like I said, looks technical. So I'm going to take my time to explain this. This is the main file. So let's copy this and then take it to our main.c. Let me remove this one since I'm not using it again. And then the main.h. Okay. So we have to copy also the second one, convert day.c. I'm going to take this. Let me call it convert.c. And then we'll paste the code here. We still have another one here, and then let's copy this also. This is called remaining days. So let me call it same. Remaining underscore days.c. So you have to paste it here. Now, the same thing is applicable. We need the main.h file, of course. So I'm going to create my main.h. Then the files or the prototype that will be in the main.h is first. I'm going to copy this prototype here. This one. And then paste it in the main.h with a semicolon. And also the remaining days needs the prototype. So I'll copy it here. And then paste also in the main.h with a semicolon. Okay, let me extend this. All right. Now, let's look at this. What is the issue with this code? That's the first thing. If you run this program, all right, from what they've given to you, this is what you're expected to have as a result: 0401 1997, 91 and 274. So if I run this, I have the same value: 0401 1997 and the rest values there. Okay, that's fine. So what's the issue? Output looks good, right? Now let's make a little changes and then try this using a leap year. Okay, so here they're trying to change the value from what was given here, 0401 1997, to 0229 2000. So I'm gonna go to my main and change the month to 02, and then change the day to 29, and then change this very one to 2000. All right, if I run this program, I'm seeing invalid date. Okay, now you are asked to correct that. That doesn't seem right. Invalid date does not seem right, because 29 is actually a day in February under leap year. Okay, to fix the print remaining days function so that the output works correctly for all dates and all leap years. Okay, I don't want to go into reading all this, so let's see how to correct that. Let me take my time to explain this code first. So let's start with the main.c. Now, what does this main.c code entails? We know how to read as included std and the rest of them. So integer main void, that's where it starts from. Integer month, day, year. That means you need these parameters: month, day, and year is provided. So printf, of course, we know how to read these parameters here. They're just two places, two place variable, 4 for month, day, and year respectively. Okay, day, convert day, month, and day. This is gotten from a function called convert.c according to my definition. So let's see what this does. What does month, day, and convert day really do? So let's see that. Let's go to convert.c. Okay, what's this? Let me try to correct this. Sorry, main.h. Okay, that's done. All right, now convert integer month and integer day. So that means the main C file needs two parameters here. Okay, so let's see. Switch month, case 2. What does that mean? Case 3. What does that mean? Okay, let me explain. Now, why are we starting with 2? Remember that in your main.c, you will need to provide the day, okay, and the month. Now, if the month is 01, assuming the month is 01, you don't need to write here 01. Why? Because the first month has 0 to 31. Sorry, it has 1 to 31 days. Okay? And then if you look at this convert.c, it is stated here if 2. That's if the month here given is 2. It means that 31 has already been captioned as what? The day. Okay? Plus any day that you add to 2. So that means if peradventure I have something like let's say my day is 2 here, you'll see 2 here. Now what it's trying to do here is that your day actually is 2 and your month is 1, and it was not captioned here. All right, case 1 was not captioned, so the program is going to return 2 as your day. But assuming I change this one to, let's say, 2, which is month 2. Now if you look at your convert.c, it's going to add that 2 to this 31 to give you 33 days. So if I should run this program, you're going to see 33 right here, which you've seen here. All right, so if you add that value, 30, is it 31, plus the second month, which is 28 days, you have 59. Okay, if you add 31 days, it keep on increasing like that, depending on how many days is in the month and how many days they are using here. So at the end, you have 334 days plus the last month of the year, which is 31. Add it to here to give you 365 days. All right, for a normal year, not a leap year. Okay, now I think that is understood. This is very part. So let's go back here. The last one here is print remaining days, month, day, and year. Okay, So we go to remaining days dot C. Now let's understand what this code does first before we try to correct the issue, because you need to understand before you correct it. Okay, now the first thing here says void print remaining days, integer month, day, and year. So that means you need to provide your month, your day, and then your year for it to be able to calculate the remaining days for you. Okay, we have 365 days in a year. Okay, so if peradventure I have something like I've spent 2 days ahead, let's say let's go to amend.c, and then I've spent only 2 days, sorry, month 1, and I've spent 2 days. So what I'm expecting to have as a result is 363 days, right? So let's run. We can see 363 days. Okay, all right. Okay, now that works correctly, that works perfectly fine. Okay, but the issue here is, if I should change this place, this day, to 29, all right, and then I change my month to 2, and then try to find the remaining days, I'm gonna have a wrong input, invalid dates, not because it is wrong, but because this is a leap year, and this program here, this my remaining days.c, does not have the correct code to print that value for me. That is what you are expected to do. Okay, if you look at this, you are expected to solve the problem in the remaining days file. So let's do that. Now, what does this if year modulus 4 and equal to 2 or 0 means? All right, because that's where you start from to understand the code. Okay, now this place actually means that there are some certain conditions that your program should follow, hence to print that result. For instance, in every 4 years makes a leap year. Okay, every 4 years makes a leap year. You can search on Google, let's say, how many interval of years are in a leap year. Okay, now you can see 4 years. That means in every 4 years makes a leap year. So what this program means is that if a year, let's say I have 2000, modulus 4 is equal to 0. Now take for instance, if you use a calculator and then type let's say 1993 divided by 4, if the result comes without a remainder, it simply means it's 0. Now let me launch a calculator and do that. Okay, so I have 1992 divided by 4 equal to, I have 498. That means 1992 is a leap year. That's the first thing. 1993 divided by 4 equal to 498 point something. That means there's a fraction. So the remainder has some fractional index. That means it's not a leap year. That's one interval. Now 1993, or 4 rather, 1994 divided by 4 equal to 0.5. That means there is a remainder, all right? That's interval of 2. 1995 divided by 4 equal to, there's a remainder here, that's interval of 3. So now 1996 is supposed to be a leap year because that's interval of 4. So you can see 499, there is nothing attached to it. That means there's no remainder. It means it's what, a leap year. So that's what this very part is supposed to tell us. Now for the year modulus 400 and then year modulus 100, you can check that too, but I don't really think it's necessary. Okay, now let's check out that. Let me end this bracket here and then comment this out. All right, as long as I've been able to find out that all 4 years is a leap year and I've given this condition. Now if year, that is 4 years, is equal to 0, which means is a leap year, what you simply do is to add +1 to my what, February. Now look at this. if month is greater than or equals to 2, okay, and day is greater than or equal to 60, day plus plus. What does that mean? Now, let's analyze it. If you look at your convert.c, you would realize that for the first time, your days must always be 31, right? Because January has 31 days in it. Fine. That's why you're seeing here 31 plus day. Now, your February, it's supposed to be 28 days for a normal year. So if you add 28 to 31, you're going to have this 59. All right. But if peradventure your leap year, which is 29 days in February, if you add to this, it becomes 60. Okay. Now, you stated here that it's 59. So there'll be a problem. So the remaining days.c here says, if peradventure your month is at least 2, because that's where the issue will come, and then your days is more than what is expected of you, which is 59. So what you do is add that plus value to the days. Assuming it is 40, no problem. Continue adding it to the days so that you will definitely change this value from 59 to the next value that is given. That's what this code means. Okay? Then you print day of the year. At least we can relate this one. All right, 366 minus days. This actually means it is going to be what? A leap year. If it is more than that, of course, it's going to be a leap year. That's this condition. But otherwise, if month is equal to 2 and day is equal to 60, write this code. Okay, what does that mean? If this condition is not properly stated, this very part here, okay, you said if year is modulus 4 equal to 0, and then it was stated here, or year is this, and then year modulus 100 equal to 0 is not. All right, this is an and statement, which means that either this or this must be true, and then year modulus 100 not equal to 0. You should do this. So now if you look at your converts or main.c file, 2000 was given. If you actually use your calculator to divide 2000 by 100, of course it's going to give you 0. But the condition was and not. So this condition does not meet what is required, but this one has actually made, so it will overlook this and then print what? Invalid date. But if I should go to my main.c and change this to 1996, which is actually a leap year, and then try to run this program, it will definitely print the correct answer for me, which you've seen here, 365 or 305 days remaining. So there is only one thing or two things you can do. It is either you come here and then change this man to or, okay, and then leave your main file to 2000, which was given. If I run the program, it's gonna be true. You can see we have 365 days left. Now, if you look at here, all this code, it's a kind of waste of should I say memory or something, because this particular one I've taken care of that. So you can simply say close bracket here and then delete this one out. If I run the program, it's still gonna be successful. Okay, so I don't know if what I've tried to explain I've really covered the topic, but if not, drop me a message. I'll do well to explain it further, and I'll be holding live class very soon. Be alert. I'll send you the details later. All right, so I think and I hope I've been able to add value to your task and your understanding in coding. Thank you very much for having me around. See you in my next video. For now, bye bye. Please do well to subscribe and share this video